from ECB means that from doing good encryption, we're doing crappy encryption. And just to show you how ECB mode over good encryption, such as ECB, if this is the over AES, if this is the original image that we want to encrypt, this is how it looks like when it is encrypted in AES using ECB. So ECB is bad. Well, there are a couple of examples: sending the information to a remote attacker, for example, sending the passwords, sending the data, sending a connection string. We can manipulate with the DNS. There are a couple of examples that we can do. Go and read the paper, and if we want to rate for the book, so you can have a more detailed information on that. But basically, those are the examples of what you can do. Well, the .NET CLR, it actually contains a signature. If now we're talking about .NET Rootkits, this is related to what you asked. .NET actually contains a signature. And in .NET, the runtime is installed inside the GAC. GAC is the Global Assembly Cache. And in the GAC, every assembly has its own signature. So if I'm going to the GAC on the machine that we're going to attack, this one, for example, and I'm going to see Windows, Assembly, GAC. Okay, if I'm going from the beginning, Windows, Assembly. Here I have a couple of versions of the GAC. So let's go to GAC 32. Let's go to, for example, MS-core-lib. MS-core-lib contains the basic class libraries. Now we have the DLL itself, only that its signature is based on the directory name. So you can see it over here, that I'm talking about MS-core-lib version 2 _ B77 something. This is the signature. So the .NET Runtime actually checks signatures, but it checks it upon the name of the directory. So I can take the runtime, take the DLL, and put it on the correct location, and it will be replaced. And from the framework point of view, everything is okay. But again, this is not a problem specific with the DLL. This is how it was implemented, right? So this is the basic steps for the .NET Runtime. Again, it is here for reference. You can use it later on. An important thing about the DLL, the deployment of rootkits into the .NET CLR is that you have to disable engine. Engine is the machine-specific precompiled image mechanism, so that even if you replace the DLL but you do not engine it back, it will still use the precompiled image, right? Go read the paper, it will explain it a bit more, but this is, don't forget to do it. Well, when I did the experiments of managed code rootkits and basically runtime manipulation, it took lots of time, and I decided that I must have a tool that allows me to perform automatically language modifications, and I didn't find any tool, so I decided to write one, and I wrote the tool called ReFrameworker. For those of you that heard of it, the previous name of ReFrameworker was NET-Sploit. Since then, I extended it to support other platforms, not just other frameworks, not just .NET, so that it is actually a generic language manipulation platform. You can actually take a runtime and write rules of how you want to manipulate the runtime so that you can inject code into it, change the behavior, and do some very interesting things. And the idea is that it provides you with all the necessary information. It can even generate easy-to-use deployers, so that all you have to do is take the output of it and deploy it on the target machine. It is easy extendable. You can, basically it's open source, so you can do everything you want with it. It comes with many modules, and you can extend them, you can add modules, you can share modules. So it is actually a platform. And the ReFrameworker module concept is based on the idea that instead of having one piece of code, let's divide the operation to a couple of generic pieces of code. This is the building blocks in which an injection is being performed. So we have a separate code for payload, we have a separate code for method, for classes, for references, and we have an item. An item is an XML that defines an actual injection. An item is the basic set of rules that says what should be injected and where. And this is how an item looks like. And this is, although a simplified item, this is an item that says, I want to inject a reverse shell into a method called run. And it actually contains all of the information needed. So we have here the name of the target binary, for example, mscorelib. We have here the location of the binary. This is where it is located on the GAC. We have here the payload attributes that defines what is the injected code that will be injected, and of course, where is the hooking point, where we want to inject the code. We don't want to inject it anywhere, we want to inject it in a specific location. So, if we're going to look at ReFrameworker, well, ReFrameworker comes with with many modules. The modules itself are saved in the directory called modules. Here you have the separation of all of the code. So, for example, if we're going to see now an example of an injection of a reverse shell. And if this is the item of reverse shell, this is all of the information needed for the tool to know where to inject the code. We can see that it is combined from a payload called conditional reverse shell form.payload. It is combined from one method and one class. The class, by the way, is netcat. We're going to implement the reverse shell using netcat. But again, this is just a way of implementing it. So if I'll run ReFrameworker, this is the UI of ReFrameworker. I'm going to load some kind of item. You can see here that there are many items that are defined that you can use. This is for many of the attacks that I described, for the backdoors, for the encryption keys, for hiding process, and many of the other stuff. And I'm going to load the conditional reverse shell. By the way, it is conditional because I want a reverse shell to open to the target machine only upon a specific execution of some kind of executable. I want the reverse shell. By the way, you all know what is reverse shell, right? A reverse shell, so for those of you who doesn't know, a reverse shell, it is something that looks something like this, that says, well, I cannot connect to the machine, to the affected machine, but I can instruct the affected machine to connect back to me. This is usually in a scenario in which you have a firewall that blocks incoming connection, but does not block outgoing connections. Okay? So, what we're going to do now is we're going to start the injection itself. So I clicked on start after loading the conditional reverse shell, and I can see here in the, that there are three modules that are going to inject, right? One payload, one method, and one class. Over here we see the progress. We see that it is being disassembled, and we see the payload was injected, and the method was injected, and the class was injected, and after that we'll see that it will reassemble back a new DLL. And if everything works as expected, it will say that everything is fine and you have a new DLL, and it will ask me if I want to generate deployers. So a couple of minutes, seconds later on, that's what I was waiting for, I see that it says me that everything is fine. And it asks me if I want to generate deployers. Remember, deployers are those batch files that allow me to inject the modified code. This is deploy.bat, for example. And if I want to go back to the original behavior, I need another batch file. This is the undeployed batch file, right? So it allows me to go back and forth and to test some kind of code, go back and do some other things. So I injected the code, and let's set the stage. So if this is the affected machine, right? Let's add the attacker. The attacker on the right, this machine, a separate machine, is running netcat in listen mode on port 1234, right? So our target will be to execute, let's close this one. Our target will be to execute a file called sensitive application.exe. So this application is the application that when it is executed, I want the reverse shell to be issued. So think about some kind of application in which there is some logic to open a reverse shell, for example, VPN or stuff like that. But nothing happened, right? This is because I didn't deploy the DLL yet, the MCR yet. So I'm going to deploy it. By the way, this is